So I think it's time to start the keynote session. So you are very welcome to the Wednesday keynote session. We have 45 minutes talk and then 15 minutes questions and answer session. So please join the discussion. I encourage you to present the questions in the Zoom to make the session more human and interactive. But now I'm very pleased to introduce our keynote speaker, Tiina Seufert. She is professor for research on learning and instruction at the Faculty of Engineering, Computer Science and Psychology in the Ulm University, Germany. Tiina's research deals with theoretical and empirical questions on how to foster learning processes by instructional means, such as learning with multiple representations, effective strategies for multimedia learning, and research on cognitive load. Her work is also contributing to the better practice of learning and instruction, since she evaluates and trains learning strategies and measures cognitive capacity and cognitive load. Tiina has published extensively in the top journals. As an example of her high-quality research, she was awarded to the 2019 EARLI Outstanding Publication Award. I would also like to add, those of you who have seen her keynote introduction video noticed that Tiina is a team player with a good sense of humor. So Tiina, the screen is yours and we are eager to hear your talk, Learners' Resources as Moderators for Instructional Design, Self-Regulation and Cognitive Load. You are welcome.
Thank you very much, Sanna. Good morning, everyone. I'm happy that you are all here, and thanks for this kind invitation. When I was awarded 2 years ago for this paper on self-regulation and cognitive load, I did not realize that it comes along with the keynote talk, but meanwhile, I coped with this challenge, and actually today I'm quite happy to be here. And I strengthened myself with a cinnamon roll. I learned to bake them yesterday. Thanks for this. That did a trick, actually. So I decided to not only talk about the issue of the awarded paper, that is self-regulation and cognitive load, but to broaden the view and give you an overview of my research agenda of the last 20 years. The bottom line of this research was most times that we investigated different instructional approaches, supporting approaches, and very often we found that despite they were really effective and theoretically very clear, we did not find overall effects for all the learners, but only for specific ones, depending on their learner characteristics and their learner resources. And therefore, the title of my talk today is Learners' Resources as Moderators for Instructional Design, Self-Regulation, and Cognitive Load. And to illustrate what I mean with learners' resources, I brought a little boy with me. His name is Tim. Oh, I have to click here, sorry. That's Tim, and he's quite good in school. He is particularly interested in arts and history and in studying languages. And during a summer school, an international summer school last year, with other international students, he learned to know Marie, and he totally fell in love with her. But the problem is that Marie is from Paris, from France, and he cannot speak French. So he needs to quickly learn French because Marie is visiting him in his class in October, and he wants to have a real conversation with her. So he would like to have a talk to her in private. So he needs to learn French quite quickly. He needs a plan to do so. And a friend of him recommends him to use the Bubble app. Maybe you know that. It's a technical device with which you can learn very fast, very quickly, a lot of words and a lot of sentences and phrases. And you can use it wherever you want, whenever you want. And Tim likes these kind of technical devices. He knows how to use it. He's quite self-officious about that. So you can see he's quite content, and he makes fast progress in learning French. But after a while, he recognizes that he really only knows a lot of words, but cannot speak a sentence. He cannot have a real conversation. So he's not quite happy and does not want to put further effort in this digital app and learning with the Bubble app. So he needs another plan, because still his goal is to have this real conversation with Marie. And he thinks back to the times before the Corona pandemic started, when he was in school with the other kids, with a teacher, and their practicing conversation was so much easier. You had feedback from the teacher, and he needed that feedback because he didn't know sometimes where he stands. So he likes to be with others and learn with others, and thus he decides to go to a language school, because this could be a much better plan to really learn conversation and speaking French. So as you can see, this plan worked out quite well again, and Tim is quite content and again makes a lot of progress in learning French. And while he's sitting there and relaxing, his mind wanders back to the summer school meeting, and all of a sudden he thinks of Sally, the cute little girl from the US, and he thinks, maybe I should learn English instead of French. Okay, that might be not a most typical learner, or Tim might be a not really typical example, but I think we as learners very often decide to change our goals, to change our plans, to change a strategy, and to use our prior experiences and our abilities when we decide what to do and when to do. And what I wanted to point out with this little example of Tim is that learning is quite a dynamic process, and that it is not only about dealing with the task and having a specific success, but that we have to ask first what success actually means. It could be, for example, that we have different learning outcomes, for example, learning a lot of vocabulary or grammar, or to have a real conversation, to learn speaking French, for example. That makes a difference. And of course, the task itself makes a difference, whether you use different learning materials, different devices, for example. You have different materials and different learning activities, therefore. So that's also making a difference for the process of learning. And I think the example made perfectly clear that the learner, him or herself, makes also a difference with her aptitudes and learner characteristics and goals and so on. And these influences are not quite direct, but it's a kind of dynamic changing process over time. That means we have to consider not only one moment, but a longer period of time during learning. And the question now is, which factors actually influence this dynamic in learning, in self-regulation, so to say. And I brought a tetrahedral model of Jenkins with me. Jenkins described 4 crucial factors for memory experiments. And I think these 4 factors can be perfectly applied to learning in general. He says that we have to take into account the learning material. And this comes along with specific learning activities, and you can reach specific learning outcomes. And these 3 factors are important, but in addition, also the learner with his or her characteristic is important for this dynamic of learning, of the learning process. So we need to take into account all these 4 factors, and particularly the interplay between these 4 factors. And this interplay has been kind of a guideline for my research, and I want to give you a kind of journey of time through this research with 3 stations. And we start where I've started, with learning with multiple representations. And after that, I broadened the view to more sometimes technical devices. You can see VR devices, for example, where we had studies recently. And the last chapter is on self-regulated learning, because I think that this is especially important whenever we learn, wherever we learn. And in learning with multiple representations and multimedia, we recognize very often that learners need a kind of self-regulation competence, and how they can be fostered is a very important issue for research. But let's start at the beginning with learning with multiple representations. What are multiple representations actually? The picture you can see here is quite a good example. The students here, they are working in a lab. They make an experiment with different substances, and they have, for example, different results, and they can note these results in a table or in a graph. They can maybe interpret their results in a textual form, or they need, for example, chemical and structural formulas, as you can see at the table behind them. So we can see that they need different representations to understand what they actually do in this experiment, to get an overall understanding of this experiment. These different representations participate in this understanding. So Let's have a closer look at the processes which are needed when learners deal with these multiple representations and need to come to such an overall understanding. And we come back to the Jenkins model and first concentrate on the learning activities and ask which learning outcomes could be possibly reached. To start with that, let's have a look at this very basic model. You can see here again that we have multiple representations. We have a text and a picture or an animation in this case. And these multiple representations need to be processed in working memory. And afterwards, they need to be stored in long-term memory. And we know from many models on learning with multiple representations or on multimedia learning, that is the cognitive theory of multimedia learning from Richard Mayer, for example, or the integrated text picture comprehension model from Wolfgang Schnotz and Maria Bannert. And they all point out that we process these multiple representations in different mental systems. That is, we have a text processing path and a picture processing path. So we have separate systems, but nevertheless, we need to integrate afterwards these information from the different representations into one coherent mental representations. And therefore, we need to take into account what we already know in long-term memory. It means we need to use our prior knowledge. I forgot to say that this is, of course, going back to previous dual coding theory. And then I come to the prior knowledge, which is very important because we not only use the external trigger, that is, we not only have a bottom-up processing, but we also have a top-down processing where we use our prior knowledge, and this helps us in selecting, for example. So this is the interplay between bottom-up and top-down processes. Let's have a closer look at these text processing and picture processing paths. And most of the models I just mentioned, they explain that the text processing and picture processing takes place in a successive levels. That means we first grasp only the text surface. We have no understanding what the text actually means. We can just recite it, for example. But then we have a semantic analysis and really understand what the text means. And this is the same as the case, of course, for the picture path. So when we link these processes to the possible learning outcomes, we can see that on the text surface or with a surface representation, we are only able to answer recall questions, for example. And when we really understood the meaning, when we have made this semantic analysis, we are able to answer comprehension questions, for example. And then when we really manage to integrate these different representations into one coherent mental representation in a mental model, so to say, which also includes prior knowledge, maybe then we are able to apply the knowledge from both resources, from all the multiple resources. But the crucial question I worked very long with was how this integration can take place, what needs to be done from the learner to really have this integrated mental representation. And therefore we have a closer look at this process of coherence formation, because you want to have a coherent representation of all these different representations. But first, of course, you have to start locally. That means you have to have a coherent mental representation of the text for itself. That means you have to find crucial concepts, for example, their interrelations. You have to understand how the first section is related to the second section and so on. So you have a network, so to say, which is locally for the text. Of course, the same is the case for the picture. And when you have multiple representations which are really interlinked, you also have to link them mentally. So you have to find correspondences between text and picture, for example. That is, we have a global mapping between the representations. And the question is, how can we find such global mapping or correspondences globally between text and picture, for example? We can refer to, for example, surface features like color. We can see that a term is printed in red, and in the picture there is also something highlighted in red, and we can see, there is something red, and maybe there is a correspondence, but we have not understood why is it red and why it corresponds. We can only see there is something. So this would be an element mapping. We map elements that are corresponding based on surface features. Or when we really understand why they are linked to each other, this would be a semantic-based element mapping. And of course, we can not only map singular elements, but also broader relations between text and picture. So we have a really broader understanding of broader meanings within the text and the picture. And this again, of course, can refer to surface features or to semantic analysis. You may see that these processes are very complex, that we have to make all these identification processes of relevant elements and have to map them onto each other. And when we not only have two representations, but even more, this process can be very complicated. So the goal for us was to ask whether we can support learners, or how can we facilitate these processes which I just described. And now I want to change perspective in the Jenkins model, and we'll take a look at the learning materials, how we can, with instructional design, instructional approaches, support these processes. And we always take into account learner characteristics in interaction with these different instructional approaches. The first study we did was a coherence formation study with deep structure level help. That means in this example, you can see, for example, a text in a picture, and below there is a yellow text box. And in this text box, it is explained how these text and picture really correspond with each other. So they explain what are the relevant concepts and how they are interlinked. However, we think that we need at least a little bit of prior knowledge to understand the concepts and to really understand the correspondences with this kind of deep level help, because you need a semantic analysis and it needs a little bit of prior knowledge at least. So we were interested in whether this help have different effects for learners with different levels of prior knowledge. And this is what we actually found. You can see here 3 lines for the 3 levels of prior knowledge we investigated. We had, with the light green, the low prior knowledge learners, with the middle green color, the medium level of prior knowledge learners, and with the darkest green, the high levels of prior knowledge learners. And what you can also see is that in the middle level of prior knowledge, these learners, they can really profit from help. This increases significantly. The other 2 groups also react a little bit, but this is not significant. So keep in mind that with the middle level of prior knowledge, this help was particularly beneficial and supportive. In the next study, we had a little bit different approach. We did not implement one specific help in one specific learning material, but we wanted to have a more sustaining approach, and developed coherence formation training. That means we trained students in dealing with many different kinds of multi-representations. They learned text reading strategies, picture reading strategies, that is the local mapping strategies, and of course also the global coherence formation strategies. And after working with the worksheet for about 2 hours, they trained these strategies for 3 weeks with their own texts and pictures and their text-picture combinations. And afterwards, they came back to post-test. And again, of course, we were interested in whether the coherence formation is particularly helpful for one specific group, depending on their prior knowledge again. So let's go to the results. And now we have to change perspectives. After the first studies, we did no longer use categories for learners' prior knowledge. We had no low, middle, and high levels of prior knowledge, but we used continuous variables. And therefore, we analyzed regression models. And you can see here the regression slopes now for the treatments. And up to now in my talk, you can always see with the light blue line, the less supported group, and with the darker blue line, the more supported group. And in this case, the more supported group is the training group, the dark blue line. And you can see with a medium level of prior knowledge, that means on the right side of this graph, there is a training effect. These learners, again, can profit from help. We did not have learners with high levels of prior knowledge in these studies because it was a highly technical issue we had here in the learning material, and we did not find experts for this kind of issue. So we can see again that we have a training effect or an effectiveness of help for learners with a middle level of prior knowledge. And in many other studies on coherence formation help, we found similar patterns. And so to summarize these patterns or these results, I developed this model where I describe prior knowledge as a moderator for the effectiveness of help. And you can see with increasing prior knowledge, the ability to use the help also increases. So you need a little bit help at least to find relevant elements, for example, when learning with multiple representations here. And on the other hand, with increasing prior knowledge, the need for help decreases. That means you don't need it any longer. For low levels of prior knowledge learners, that means they would need the help, but they cannot use it. It's too complicated for them. They struggle even with identifying the most relevant things. And for learners with high levels of prior knowledge, they are able to use the help, but they don't need it any longer. So in the middle level of prior knowledge, we have a kind of ability as enhancer effect. That means the aptitudes, the resources the learners have, their prior knowledge, they can be used to really use and apply what is asked for them in the instructional support. So it enhances the treatment in a way. For learners with high levels of prior knowledge, on the other hand, we can see an ability as compensator effect. They don't need the help actually, so they can compensate whether the help is there or not. It doesn't matter for them. And there might be even an interfering effect. We will see this in a few studies, and we also know the expertise reversal effect, for example, that it can even reverse this when learners are provided with help they do not need, or which even interferes with their own strategies, for example. So that was the first chapter. Now we go to the next one, to learning with multimedia. Again, we want to take a short look at the processes which are needed when learning with multimedia, on the learning activities and the possible learning outcomes. And first, of course, I want to take a closer look again what multimedia actually is. What is multi in multimedia? We very often have multiple codes, for example. This is quite similar to what I already explained on multiple representations. We have text, picture, tables, and so on, different multiple codes. And very often in multimedia learning, we also have multiple modes. That means different sensory modalities are addressed. And from the well-known models, for example, cognitive theory of multimedia learning, we know that like for the different codes, we also have different mental systems for processing different modes. That is, we have a visual processing and an auditive processing path. And this goes back to the to Baddeley's working memory model, and it's called the dual channel assumption. Most of the models on learning with multimedia also agree that we need to take into account learners' working memory capacity because it is limited. This is the limited capacity assumption. Within this limited capacity, we have to deal with all these multimedia presentations. We have to connect them and to follow or to apply all these processes I just described. So we need resources in our working memory to deal with these affordances of the multimedia presentations. And there is one prominent theory that describes the specific affordances or how we deal with it, and that's the cognitive load theory. The intrinsic load is an indicator of this interrelatedness I just reported about, so that things are highly correlated with each other and interrelated. And when we devote mental resources to understand what is intrinsic to the material, to these complex things, we can call these germane resources because it is germane to the learning goal, to the learning task. Very often in learning materials, there are nevertheless processes needed which are not germane to the task, but extraneous. That means you have to look for correspondences, or you have to navigate, you have to search for things, you have to look back and forth, you have a split attention and so on. So that's not germane to the task, but it hinders you from learning actually. All this happens within our working memory and needs to be taken into account. Until now, I had a very cognitive focus with all these theories I just reported on, and I want to particularly point out one theory which was developed by Roxana Moreno. That's the cognitive affective theory of multimedia learning, and she points out that we need to take into account also motivational factors and self-regulation of learners when we want to understand what really happens, and for example, when we want to address the different approaches in which learners can be facilitated. And this is what I want to show you next. Again, I want to show you different learning material approaches, instructional approaches, which we analyzed in interaction, of course, again, with learner characteristics. And I want to start with 2 studies where we really tried to follow all these theoretical assumptions that we wanted to have a very clear instructional design, and wanted to know whether these also interfere or interact with learners' aptitudes, whether aptitudes can enhance, compensate, or interfere with these instructional support. I have chosen 2 studies on the modality. The first one is one on the classical modality principle. That means we compare different representations. The one is visual only with a printed text in addition to a picture. This is, you can see above. And below you can see the audiovisual condition where the text is not printed but presented audiovisually. And with this, of course, you can better use the 2 mental subsystems, the 2 memory systems, and this should be more effective for learning. So the audiovisual condition should be the theoretically superior one, but it might, of course, depend on learners' memory capacity. And this is what we investigated. We found that for learners with low capacity on the left side, you can see again the less supported group, the visual only group, and the high supported group, the audiovisual. And for the low capacity learners, the audiovisual condition is in fact better. That's the classic modality effect. But with increasing capacity, this effect can be compensated for. So learners with more capacity, they don't need this specific use of the 2 memory systems. They can deal with their larger capacity, even with the visual only condition. And for the audiovisual condition, the effect even reverses. Maybe they have capacity to have reading strategies with printed texts, which are quite good, and this text is stable, so they can use these self-regulatory strategies within their large memory capacity. So the effect even reverses. On the right side, I brought a study with me where I did not investigate a cognitive aptitude, but a more effective one or motivational one, that is modality preference, because learners sometimes prefer to read a text or to listen to a text, a visual or an auditory preference. And the question is whether you really learn better when you get what you want. So when you really learn with a visual preference with visual text and with an auditive preference with an auditive text. We had a text on volcanism, and you actually can see here that we have interfering effects when you learn in your not preferred modality, but that this interference is particularly strong for the visual preference groups. These are on the right side. There you can see the visual preference group, they really learn better in their preferred modality with the visual text. And for the auditive preference group, they also have a little bit better results for the auditive modality, but they also can really quite learn quite good with the printed text. We think that, of course, everyone has strategies to deal with printed text because we learn it in school. So even if you have an auditory preference, you are used to deal with printed text, but that might not be the case for the auditory text, where you might not have really good strategies. So when you have a strong visual preference and are used to use visual text, so you might struggle with the auditive text. This is what we found here. So with these 2 studies, we tried to provide the most effective learning material. So the approach was really to support learners. And with the next 2 studies, I want to show you a completely different approach. The idea is not to provide material which is less, very smooth and easy to follow, but which is less effective and less smooth. So you can have challenges where you have to find the most important things, and it's difficult to find them. And the idea is that it is a difficulty implemented which should activate learners. That is, you make something more difficult in order to awaken the learner to say, hey, you have to take a closer look, and maybe this works. But again, of course, it can depend on learners' aptitudes, which can enhance, compensate, or interfere. And we investigated 2 difficulties and asked whether they are really desirable. Namely, the first one was background music. That on the left side, you can see this study. It was on time zone with time zones on Earth, a text picture material, and we had additional background music. And the idea could be that, of course, the background music could be irritating and hindering, but it could also enhance learning because it maybe activates learners and is more motivating. So maybe that depends on learners' memory capacity. So we were interested in these results, and this is what we found. Actually, for learners with a low capacity, they really learn better without the music. So they struggle. It's a difficulty, not a desirable one for them. And for learners with higher capacity, they can compensate. But what we did not find was that we have an enhancing effect. There was no activating effect of the background music. Even with high capacity, you can learn with both conditions, but you're not better with the music. So we only have a compensator effect here. On the right side, you can see a study on the disfluency effect. You might heard of that. That's the idea that we have disfluent text printed in an illegible font. You can see here this Hettenschweiler font with this gray. You cannot really read it very smoothly, so you have to take a closer look. And in comparison to a fluent text, you might have to invest more resources, but you need more resources. So again, we are interested whether it interacts with memory capacity. So this is what we found actually, that in fact, when you have low capacity, this disfluent text is disturbing and you cannot learn really good with it. So you have inferior results with the disfluent text. But for learners with high capacity, there you can see a really enhancing effect. With increasing capacity, first you compensate and afterwards you can really enhance and go deeper and look further because you have the capacity to do so. You see there is something difficult and you invest more resources. Particularly with this last study, I think it's very important to take into account learner self-regulation because of course, you need the memory capacity to be able to use the trigger of disfluency, but you need also be willing to use your resources. So you need to make the decision to deliberately invest more resources and go deeper and look further with this disfluent condition. So therefore, I want to come to the last chapter, that is self-regulated learning. And again, I want to very briefly go into the processes which are needed when learning with in a self-regulatory way. So again, we have to take a closer look at the learning activities and the possible learning outcomes. When you learn self-regulated, you still have to deal with the task, of course. There is a task and all the processes which I described until now are needed. That's the object level. But in addition, when you learn self-regulated, you have to deal with yourself. You have to manage your own learning process. And that means there is a meta level where you have to manage all these learning processes on the object level. You need to plan, you need to monitor yourself, you need to regulate, to adapt your learning behavior. And this is not only in one direction, but also circular. We have these different models on self-regulated learning, which shows that. So we need a meta level and an object level, which need to be managed and orchestrated in a way when learning in a self-regulated way. And therefore, again, we wanted to ask how we can support learners on these different levels. And we investigated a lot of different approaches. I just brought two of them with me, different learning materials. In this case, it was instructional prompts, in addition to learner characteristics. The first study on the left side is an elaboration prompt. That means it's a prompt on the cognitive level, on the object level. We implemented it in a VR environment. You can see here a VR on a robot, for example, and we asked learners to pay attention to concepts and terms that are new to them and how they are related. So they needed to find the most relevant relations between them. And they should imagine to explain them to someone else. So it's a classic self-explanation or other explanation prompt, which is used very often. And we can very often see positive results with these kinds of elaboration prompts. We were interested whether these prompts are related to learners' prior knowledge. Maybe it could help to find most relevant things. So you can use it even with low prior knowledge, or maybe you again need some at least basic bits of prior knowledge to use this prompt. And this is what we found. In fact, the prompt is helpful for learners with low levels of prior knowledge. The prompt seems to be quite easy to follow. You just have to take a closer look, and you are advised to search for relevant concepts. This focuses your attention in this very rich virtual environment. So we managed to really focus and help those learners. For learners with high levels of prior knowledge, they were irritated kind of with these prompts. They didn't need it. So these processes are not necessary for them to take a closer look or to pay attention. They were focused on themselves, and they didn't need this specific prompt or to explain something to others. So that was interesting for us. Maybe you have an idea why that happened. Later on, we can discuss it. For the metacognitive prompt, we implemented a metacognitive prompt. That means we addressed the meta level. We asked the students, please think about the following. Which main points haven't I understood yet? So they monitored themselves. And we thought that this could be particularly helpful and supportive for learners with low self-efficacy, because when you see where you already stand, what you already know, this could be kind of booster for your self-efficacy. So this was another aptitude, again, a motivational one, and we were interested in the effects of the prompts depending on that. So you can see almost the same pattern as on the left side. Again, we can see that the prompts are particularly helpful, in this case for low self-efficacious learners. They needed that prompt, or they could use this prompt for improvement in learning outcomes. So maybe mediated over their increased self-efficacy. And for learners with high levels of self-efficacy, they didn't need that prompt. They were even a little bit less good in learning. So again, an interesting result. And this does not really match to these results on learning with mild representations, where the middle level of learner was especially sensitive. These prompts seem to be particularly helpful for learners with low levels of self-efficacy or prior knowledge. That means with less resources. Maybe we can discuss that later. So I want to summarize. These were a lot of studies, and we very often found effects of instructions depending on learners' aptitudes. Sometimes they could use the trigger, sometimes they needed the support, sometimes they are irritated or can simply compensate for it. And so to bring all this together, I want to summarize. And I want to show you again the Jenkins model and show you what we have seen in all these studies with reference to the learning material. For example, we analyzed multi-representational studies, multimedia studies. We analyzed instructional support on the one hand, and desirable difficulties, or sometimes only difficulties, on the other hand. And we were interested in the learning activities, particularly coherence formation and self-regulation. And of course, we analyzed different levels of learning outcomes. Maybe you have recognized that in the talk. Sometimes there were different levels, for example, recall, comprehension, or transfer outcomes that we measured. And of course, we analyzed in every study learner characteristics, the more cognitive ones, prior knowledge or memory capacity, spatial abilities, and on the other hand, the more motivational ones, the learner's preferences, for example, or the self-efficacy. To structure all this, we can say that at the bottom, we can see the task affordances, what the task brings with it. And on the top, you can see the resources which learners can use to deal with these task affordances. And with this interplay of using the resources for dealing with the task, we have to keep in mind that we have maybe not a direct way, but a regulatory process way, which is again mentioned with this circular arrow. So I was particularly interested in the question, when do learners and why do learners regulate? And this is what I published in this paper, which was awarded 2 years ago. And there I describe this regulation process, which is, for example, illustrated by the example of Tim. And the regulation is there described as a function of resources on the one hand and imposed cognitive load on the other hand. You can see this curve of regulation, and it depends on task difficulty. With increasing task difficulty, the resources to deal with the task decrease and load increases. And I want to elaborate a little bit on it. When you, for example, have a low task difficulty, you have sufficient resources. You simply use the resources. You don't have to regulate, to adapt, or to change. You just deal with the task. So there you don't have to regulate so much. With increasing task difficulty, you have resources and the load is there. So you need to change, to adapt, to go deeper, look further, and so on. So you might regulate the most. With increasing, with very difficult tasks, on the other hand, we would like maybe to regulate, but we cannot because we have no resources left. So this is the idea. And to have a little bit a closer look what actually task difficulty means, I want to point out again, with reference to the studies I just reported, that we have to take into account the object level and the meta level. The task can also comprise the meta comprehension and metacognitive processes. This comes along, I think, with task-determined and self-determined task difficulty, because we cannot really be for granted that only the task brings affordances with him. The learner, him or herself, can decide to do more or less. Because I'm interested, because I want to go further, or because I'm not interested, I want to skip half of the task. So we have task and self-determined task difficulty, which need to be taken into account. I think I made quite clear that we have to address the different resources, the cognitive ones, the motivational or even emotional ones. That's what we haven't investigated by now very often. And I think we have to take into account that these resources can be influential or situational. That means state-like, or more overarching in a trait-like way. One important point I want to make is that for the imposed load, we have to differentiate between load and effort. That means what comes from the task, that would be more the load aspect, the loading aspect, or what is invested, again, self-determined by the learner, him or herself, that would be the effort he or she invests. And to investigate or to validate this model, we made a few studies, first attempts of a validation, so to say, and I brought 2 of these studies with me. And the first one is that we were particularly interested in whether this interplay between resources and load actually can be seen in a study where we had a strategy training. The idea with the strategy training is that you decrease task difficulty because you increase resources. You increase the resources because learners have strategies, knowledge at hand, and they know how to deal with these strategies, to use these strategies. And therefore the load could be affected. But we were interested in which kind of load is affected. Is it the effort? Is it the load? So we analyzed both. So in this study, we found actually that the learning outcomes were increased with the training. And I think this is a kind of indication of that really there is kind of regulation. And we actually see that the mental effort also increases on the one hand, but the load decreases. What is it behind effort and load? How did we measure? How did we ask for effort and load? I brought the items with me. We asked learners, I inserted myself. That means I actively invested. And in one of our newest studies, we found high correlations with germane cognitive load. That is, we used both questionnaires, the differentiated questionnaires on germane intrinsic and extraneous load, as well as this active and passive or load and effort scale. So we asked for the active part, I've inserted myself, I invested something actively. And the passive part, that means the load, we call this passive because it happens to you, because the material affects you in a different way, in a specific way. The material was training to me. You have no control maybe over that. And this actually was correlated in our new study with Melina Klepsch, which we just published in spring, that it is highly correlated with intrinsic and extraneous load. That means the task-related parts of cognitive affordances. So I think this shows that it is worthwhile having a closer look and a differentiated look at load and effort, and to also differentiate between germane, intrinsic, and extraneous cognitive load. In the last study I want to show you today, we were particularly interested in whether this U-shaped curve actually could be validated, whether we find this U-shaped pattern. And therefore, we again use the disfluency effect. And we had different levels of fluency or disfluency. First a fluent condition, and then 3 disfluent conditions with increasing disfluency. The last one was very illegible. And you can see here the results on the left side, the learning outcomes. And the learning outcomes again have this U-shaped curve, and in my view, they can be seen as a kind of indicator for this regulation curve. What happens here? The fluent condition, there you don't invest too much effort. This is what you can see in the middle graph. And for the last high disfluency, you have less learning outcomes because it's too highly loading, as you can see in the extraneous load chart. So you invest effort for all the disfluency conditions, this you can see in the middle, but it doesn't pay off any longer when extraneous load is in addition too high, so the learning outcome decreases again. So this is what we think can be a first indication of this interplay between resources and load and effort. And of course, we are interested in whether all this can really be validated, and these are only first steps. So we have a lot of future challenges. Of course, we are still interested and every time interested in how to improve learners' resources, how to enhance learners' resources. And we are particularly aware that we need to take a closer look at task difficulty and to understand what tasks actually bring with them. What are task affordances in order to understand what they bring with it, but also to match them to learners' resources more adequately, for example. And of course, I think I made that point. We think that it is important to measure load and effort differentiatedly, and to also measure the 3 parts of cognitive load based to the original version of cognitive load theory differentiatedly with the different scales that we have at hand. And overall, of course, we are interested the most in this regulation and in what happens, what does the learner do, which decisions he or she takes, what are the dynamics of regulation, and to capture really the processes of this regulation. I think, therefore, there are very, very good approaches, for example, the multimodal measurements of self-regulation of this group of Sanna, for example. And we need to have process data to take a closer look at that and to understand the dynamic over time also, and to, in the end, learn more about learning. That's what I wanted to tell you today. But I want to end my talk with a big thank you. Thanks to all these colleagues, guys, collaborators, co-workers and friends, particularly those of SIG2, for your inspiration, for your support, and for your very good ideas and fruitful discussions we had when we had real conferences where we were together in presence. I missed it very much. And of course, my very warm thanks and many, many thanks to my team. Without you, it wouldn't have been possible to make all these studies, and I only brought a few of them. So many, many thanks for your support, for your endless support, and for your big heart. Thank you. And of course, thanks to you for your attention. And I'm very happy if you have some questions for me and I could answer them. Thanks.
Thank you so much, Tina, for your clear and deep and interesting talk. I'm sure that actually you have a big audience here, so I'm sure that there are many questions now. And I perhaps if you close your presentation, we might be able to observe better that if there are, we have a bit more than 10 minutes time for questions. So raise your hand. Let's try first if we are able to do the questions like in this Zoom. Not.
I want to say there is already a question in the chat actually, if I may read it out loud. Yes.
Yes, please.
It's from Jürgen Schneider from the University of Tübingen. His question is, doesn't the efficacy of help also depend on the type of help given? I suppose there is a type of help that is hardly effective for students with low prior knowledge, but less so for students with middle prior knowledge.
Yeah, of course. I think this could be perfectly seen with these last studies on the prompts. This is the kind of help which is easy to follow. You have a prompt, take a closer look or underline something, so you can follow this prompt quite easily. On the other hand, the help that I reported at the beginning with the coherence formation, this is quite sophisticated. You really have to take into account all the different representations, find the correspondences, and that's highly complex. So you need additional resources to be able to follow to that. So of course there are more sophisticated types of help and a low levels type of help, and we could align these. That would be the goal, to the resources the learners have.
Right, thank you. I hope that answers his question. Thank you so much, Sheena.
I hope too, otherwise he or she can just...
Yeah, I think I can find another question here. No, I think this was already asked.
Yeah, there's one more.
So if you find the question, please.
Yes. There's one more question from Jean-Michel Boucher. How to train pupils to self-regulate, for example, to manage themselves limited resources? What type of training strategy?
Yes, in fact, my question was, hello, Tina. My question was about, how to train, because I think there are not many research on the type of training in a dynamic way over time, how to train people to self-manage their resources, depending of the type of task, of the difficulty, etc. So, of course, you can ask people to self-question, for example, or to self-explain or something like that. But I think there are, potentially many type of strategies that can be used. Not always at the meta level, but also at the procedural level. So explaining people how to manage their resources. I don't know if there are many studies about this type of training or.
There are many studies about these types of training, actually. And I think the focus, you described it quite well, the focus was very often on training strategies to deal with specific materials or to deal with specific external affordances. But what we do not take into account into these trainings is that we could also make learners aware of their resources, what they know and what they do not know, because depending on their resources, they might need other strategies. They might skip or can enhance or elaborate. So I think this self-awareness and self-monitoring, not only concerning the actual behavior while learning, but also concerning the resources we have, preferences and so on, memory capacity, motivational state and so on, this could also be highly relevant. And I think the EFG group, which addresses this effort monitoring, is in this direction that we make learners aware of their effort, their current effort, so they can use this as a cue for further processing, for example. But that could be also aligned with the monitoring, not only on the effort, but also on the resources underlying this effort. Why do I have more effort maybe than another one? So these are maybe interesting questions to go ahead.
Yeah. Thanks.
There is actually one question in the new question. Could you elaborate on how your model could be used in the dynamic of progression along learning?
Not yet, because I think there is a lot of work to do on this. Yeah, on these changes. I wanted to point out, of course, with my little example of Tim, why do learners decide and when? And so I think it would be very interesting to have this analysis of this regulation curve, which is not singular, one-dimensional, but multidimensional. You can have task difficulty at the beginning, which is quite low, but then it increases, and then you get used to it and it decreases again. So we could use this kind of model as a framework to describe what happens during learning. And I think it's the main message is to take into account all these forces that affect the regulation, the actual regulation, and to measure that online with process data. That would be very helpful, I think.
Now I think we have 2 hands there. At least I can see Peter hands up. Can you ask your question?
Julian was first. Julian, please go.
Julian was first, yeah.
Thank you. Thank
First.
you. Tina, I very much liked your model that relates task difficulty to regulation. And I wondered whether you think that dependent on the task difficulty, learners would change the type of regulation. For instance, if you have very much resources left, you can engage in more sophisticated regulation strategies. And do you also think that it would be important to inform learners about if not intensive types of regulation when engaging in these tasks?
Yeah, I just had difficulties to hear the last sentence because of technical problems. To make them aware of what? Could you please repeat?
To also make them aware of different ways to regulate in the respective tasks, because I think there are more effective and maybe more load intensive and less effective and maybe less load intensive types of regulation in each of the tasks that you related to in your presentation. Do you think it would be important to inform them or to train them in this regulation activities?
That could be a good idea. Maybe you should do that. I think it could be worthwhile because yeah, I think it's important to have a matching between task affordances and the strategies you use and an awareness of the imposed load, for example, but also on the possible imposable effort you have. So I think it's good to make learners aware of all these different facets of this curve and to investigate this. But I have to think about your idea about these different levels of regulation. So maybe we can discuss it later on. So I think this could be an interesting thing to go ahead with.
And now we have a question from Peter.
Yes. So the more traditional approaches to aptitude treatment interactions have mostly been based on finding stable learner traits that interact with treatments. Mm-hmm. But as far as I'm aware, apart from rather robust effects of prior knowledge, all the other effects with spatial abilities, other cognitive abilities, personality, whatever, are really rarely found. And so do you think that this more classical approach to aptitude treatment interactions is dead apart from interactions with prior knowledge, or is there still hope that we can also find interactions with other student characteristics that are stable, robustly found, that help us?
I think that both perspectives are necessary, that we need a trait and a state. I think the state can be enlightening when we particularly take a closer look at this dynamic process over time, because self-efficacy, for example, seems to be quite stable, but we found in studies that it is even changeable a little bit in ranges, of course, over time when learners have, for example, a hypermedia learning scenario with different chapters and different sessions. So there are changes over time. And I think, therefore, maybe artificial intelligence could be helpful to measure very often and to adapt learning materials while processing and analyzing these things. So learning analytics and all these multimodal process data we could use could be helpful to disentangle what is actually a stable state-like thing and what is behind this state in a way of a trait. So where does this state comes from and why? And of course, we can address both perspectives. I think that would be more fruitful.
Okay, thank you.
Okay, I think we have 1 minute time to, and it's time to close the session, but I would like to thank you for bringing this very strong cognitive perspective to the discussion in regulation. There are quite many of us also in the audience who are considering the regulation in a more contextual and social and interactive and broader perspective, and reminded us about the deep roots of the regulation in that research. I think it's time to close this session. Thank you, Tina, very much. We enjoyed your talk, and thank you for the audience attending, and I wish you very fruitful rest of the conference day.
Thank you, Sanna. Thank you for being here.